me again. I'll be reading part 3 of question 3. Where did the instructions come from? There we go. It is about ants. If this museum had a huge store with millions of items for sale and they were all so tidily arranged that you could easily find any item you needed, would you assume that no one had organized the place? Of course not, but such order would be a simple feat by comparison. In the museum display, a sign invites you to take a length of this rope in your hands for a closer look. 5. As you run it between your fingers, you see that this is no ordinary rope. It is composed of two strands twisted around each other. The strands are connected by teeny bars, evenly spaced. The rope looks like a ladder that has been twisted until it resembles a spiral staircase. 6. Then it hits you. You are holding a model of the DNA molecule, one of the great mysteries of life. A single DNA molecule tightly packaged with its spools and scaffold makes up a cornerstone. The rungs of the ladder are known as base pairs. 7. What do they do? What is all of this for? A display sign offers a simplified explanation. A feat of engineering how DNA is packed. Packing the DNA into the nucleus is an amazing feat of engineering, like packing 24 miles of very fine thread into a tennis ball. The ultimate information storage system. The key to the DNA, the science lies in those rungs, the bars connecting the two sides of the ladder. Imagine the ladder split apart. Each side has partial rungs sticking out. They come in only 4 types. Scientists dub them A, T, G, and C. Scientists were amazed to discover that the order of those letters conveys information in a sort of code. You may know that Morse code was invented in the 19th century so that people could communicate by telegraph. That code had only 2 letters, a dot and a dash. Yet, it could be used to spell out countless words or sentences. Well, DNA has a 4-letter code. The order in which those letters A, T, G, and C appear from words called CODONS. CODONS are arranged in stories called genes. Each gene contains on average 27,000 letters. These genes and the long stretches between them are compiled into chapters of a sort, the individual cornerstone. It takes 23 cornerstones to form the complete book, the GENOME, or total of genetic information about an organism. The footnote reads, each cell contains two complete copies of the GENOME, 46 cornerstones in all. End of footnote. The GENOME would be a huge book. How much information would it hold? All told, the human GENOME is made up of about 3 billion base pairs or rungs on the DNA ladder. Imagine a set of encyclopedias in which each volume is over 1,000 pages long. the GENOME would fill 428 of such volumes. Adding the second copy that is found in each cell would make that 856 volumes. If you were to type out the GENOME by yourself, it would be a full-time job with no vacations, lasting some 80 years. Of course, what you would end up with after all that typing would be useless to your body. How would you fit hundreds of bulky volumes into each of your 100 trillion microscopic cells? To compress so much information so greatly is far beyond us. A professor of molecular biology and computer science noted 1 gram of DNA, which, when dry, would occupy a volume of approximately 1 cubic centimeter, can store at as much information as approximately 1 trillion CDs compact discs. What does that mean? Remember, the DNA contains the genes, the instructions for building a unique human body. Each cell has a complete set of instructions. DNA is so dense with information that a single teaspoonful of it could carry the instructions for building about 350 times the number of humans alive today. The DNA required for the 7 billion people living on Earth now would barely make a film on the surface of that teaspoon. End of part 3. Bye for now.